Hello. In this video, we're going to show you how to use the SPARKvue data analysis tools to determine at what temperature should you be putting your cold metal into the hot water calorimeter. You can see that in this particular data run, when we started accumulating data at time equals 0 seconds, that the temperature was about 56.3 degrees. We then let it decrease to around about 55 degrees, at which point we put the cold metal in and the temperature dropped. But how did we know this was the right moment? We had to wait from 0 to about 240 seconds. That's roughly 6 minutes. How did we know that after 6 minutes of waiting, this was the right time? That's what you and your teammates are going to have to decide. So what you can notice is from the moment we started accumulating data, the temperature was decreasing, but it was very unsmooth up here. See how it's just kind of oscillating back and forth? At some points, it actually starts to go up and it's going down. This is because we weren't stirring it very uniformly. You're going to want to stir it constantly and smoothly, but even then, you're going to see some temperature fluctuations. But eventually, after about 5 minutes, we saw right in this region here, the temperature started, it's still decreasing, but very smoothly, very linearly. This is the region where we knew that the water was basically ready for the cold metal to go into it. But we were also measuring the slope, and that's what you're going to want to be doing. Remember that when you're accumulating the data, you're not going to be seeing all of this out here. You're just going to see it start at 0 and start to come down. So you're going to want to measure that slope, and this is how you do it. So when your data is on the screen, you want to make sure not that the hand is depressed, but make sure that you're actually hovering over this square tool here, right? This is the toggle move select mode button. When you press it, the square lights up as orange, and now I'm able to highlight any region of the data that I want. I can draw just a really big square, and now I'm telling SPARKvue that anything within that square are the data points I want to analyze. You note I can left click inside that box. I can drag the box wherever I want it to go. And you're going to have a small amount of data, so make sure your box is small. So you can always click on one of these little blue circles in the lower corner, and I'm going to drag a box like that. So then I can have the box over the data, and you'll be doing this in real time as the data is coming in and monitoring the slope to let you know when is it flat enough for you to add the metal. So once you have this region of data highlighted, you can see the yellow points will be fit with a line. Go down here to this Show Hide Linear Fit button, press it, note that it becomes orange, and now you're having a fit to just those yellow data points. The red line extends over the whole screen, but it's just fitting the data points within your drawn box. And we already set up here, it was too rough. The temperature was not stable at all. Also, the slope that we were reading, which is M, was negative 0.00721. That's degrees Celsius per second. That's going to be probably too large a decrease to accumulate good data. So we waited and we waited and we waited and we waited till a longer time until finally about here. I don't want to include the points that are actually where the temperature is changing. We were looking at something like this, and we saw that, yes, the data was behaving very, very, very well, and the slope was about negative 0.00602 degrees C per second. And we determined at that time we were ready to put the metal in and the temperature dropped. If you can wait until that's below negative 0.005, it might behave better. But as was said in the pre-lab, you don't want it to get too cold either. So we had a reasonable slope. The temperature was about 55 degrees. And at that point, we decided that's when the data was ready to be accumulated. When you have a region highlighted, you can always also zoom in on it by pressing the scale to fit button. And now we can see, was that fit actually good to that or not? And it looks like that was a pretty good linear fit. If I want to scale back out, I can do something like clicking in that box, getting rid of it, pressing scale to fit, and now all the data comes back on. You can always get rid of a data fit by clicking in the box and clicking that blue X, or else I could have just untoggled it down from this menu here. So remember, what you're looking for is the region of the temperature decrease where the water is smoothly and hopefully slowly decreasing in temperature, where the slope is around negative 0.005 degrees C per second, and it's not fluctuating and making these really large jumps. If you do that, that'll maximize your chances of gathering good data in this experiment. So good luck with that.